here it is the focus point of the laser as well, in a pivot point of one rotating axis. And this has the specialty that we have less compensating movements, and therefore, less possible, let's say that
issues, right?
Yeah, less issues with the accuracy.
When we talk about that, honestly, Christopher, I mean, how much of us are getting into the automation side of things, and how many times has somebody who started automation invested and then walked into their shop and have found scrap pieces? So how important is that quality of the kinematics, the precision that you're talking about?
I think it's very, very important because we're here in the field of microns to achieve, and therefore it's very, very important to have this precise and special kinematics. I will show you.
Yeah, let's take a look. So when we talk about microns, there are most people that watch our channel because they're engineers and machinists. They understand what a micron is. For those of you who might not know, just imagine the diameter of the hair on your head being massively larger than what a micron is. And a micron can change with just a couple of degrees in temperature in any room you're in, which is why we have these rooms that are temperature controlled, right? So we are in the micron world. So let's look a little bit more at the machine itself, if you don't mind, Christopher.
No problem. You see inside there's the kinematic structure. We have on the bottom the Z axis. I will move that for you a little. See that? And on top of that, the rotating Z axis is what I mentioned before, that the focus point of the laser is in that pivot point. See here? Moving like that. The special about that is if you have tools, complex tools, for example, tap cutters or some profile cutters, and you have a switching clearance angle, for example, then in this machine you don't have much movements. It's just slight and turn the Z-axis, and that's perfect for accuracy.
Well, is there anything I've left out that I've not asked you about that you'd like to share with the audience about this machine itself? Because for me, looking at it, and I'm one of those people who just love machines. I mean, this is a beautiful looking, high quality machine. And if I trust Vollmer, which I know I do, and I know a lot of customers out there do, it makes common sense for me to go, well, I trust them already. Let's take a look at their laser machines now, right?
Sure. I think the quality Vollmer stands for is in this machine too. So if you are satisfied as a customer with Vollmer machines, you will be with the laser as well, for sure. One thing in the inside, one special thing I will show you, is this fixed beam guide house. Come a little closer. You have here in the back of the machine is the laser source. The beam comes inside the beam guide housing. There are the beam forming devices placed, and we have no movement in the beam guide. That's special at this machine, and it's really great because we have as well no movement in the focus point. So therefore, accuracy as well. And our test showed that this machine is very, very reliable when it comes to the accuracy.
Well, I have apparently some questions that have come in, but it's not coming in on my phone right now. So I'm going to have the guys in my ear actually read that question to me, if that's okay. So thank goodness we have a good team for that. Actually, it's coming in now. Vollmer is a great company and machines. We have thank you for this live stream from Spain.
Sure, no problem.
Made in Germany is best for machines. So these are some great comments that have come in. It's a thank you, right?
Thank you guys. It's great.
So with that being said, thank you. We're actually going to send this over to Rowan right now, the MTD counterpart, and we're going to talk a little bit more about some of the grinding opportunities on another machine. So with that being said, take a look at the Rowan's machines that we're talking about over here and enjoy.
Thank you very much, Tony, and that laser is very cool, but I don't want to steal your thunder. I think this is a little bit cooler. I know that's brand new. This is also fairly new, Alex. We're here in front of a grinding and eroding machine. Now, can you explain, first of all, why you would want to combine two, an eroding machine and a grinding machine?
Yeah. We took over our, our kinematic structure from our tool and cutter grinder, the V-Grind 360, what we launched a long time ago. And now we launched that also into our V-Hybrid 260. That means we have now two processes together. That means grinding and eroding in one single machine.
And what we're looking at right now is at the bottom here is the eroding wheel, and above you can see the grinding wheel. Now, Vollmer are known for grinding machines and eroding machines, but they're separated. I mean, there's a lot of benefits to doing them in one process.
Exactly. There are really a lot of tools on the market which enables to have both technologies, and especially the machine is done for this kind of tools, right?
Yeah, and as we can see in the demonstration here, there is a PCD tool in the HSK holder, and the eroding wheel is, there'd normally be like a dielectric fluid, but just for the demonstration we can't see it right now.
That's correct.
And it sounds to me, I've only seen physical grinding machines back in the UK when I've done some videos on them, but I've never seen an eroding machine. Let's go back to basics then. Why would you need an eroding machine?
First of all, it's the flexibility itself. We have a high flexibility due to the two processes we have. That means that there are really a lot of tools in the market which really enables two processes, but also there are customers who does not really know right now if they want to go to the erosion or they want to go to the grinding.
Because there's two kind of almost different markets. Let's go around the corner because we've got, we're going to show the tool changer in the back of the machine, but also there's a drill here I'd love to have a quick look at. So first of all, we have a look at this drill here. Now,
yeah, exactly.
Alex, can you explain why this drill is perfect for the V-Hybrid 260?
Yeah, that's a perfect drill for the V-Hybrid 260 because I have a combination I have to do here. We have the PCD in front. This is what we have to do by eroding. Yeah, with our new generator, that's the latest generation we have, where we really can reach also very good surface finish, up to RA 0.05. That's close to the grown surface finish. But in the back, we have still the carbide. And doing carbide by erosion, it takes a very long time. And due to that, we have to do a combination, eroding of the PCD, afterwards grinding of the carbide.
So it's you're getting the best out of both processes. You get the ability of erosion to go through the PCD with still a good surface finish, and then can really just grind out and whap out the flutes in the drill. Exactly. Okay, so we've talked about the machine and why you need it. Let's talk a little bit more. If you see Chris right there, have a quick look. We've got a full automation cell. We wouldn't even thought it for the size of this machine, but I mean, there's a huge mix of tools in here. Surely you need loads of different wheel sets as well in the back, right? Exactly.
We have, as you see, the flexibility of tools. For sure, we need a different kind of electrodes and grinding wheels in. You cannot have it. You cannot handle it with one or maybe two wheels we have in the machine. We need to have flexibility in the chain rotor.
Okay, so let's have a quick look. Come on, let's get the cameraman over here. So we're going to go over here, but there's a tool changer back here, and I've not seen a grinding machine with so many different tools. And these are because you need to handle a lot of tools. If you've got electrodes, you've got grinding wheels. There's also a kind of a double grinding wheel on both sides, I guess, for access reasons or for two different sides.
Exactly. Depending on the tool, or the operator is able to select the wheel he's needed in the process. And the machine is doing automatically the change, but also the dressing of the electrodes, but also the calibration with the probe.
Brilliant, thank you, Alex. And let's go a little bit more higher level now. So we've talked about the technicals, why you would need to combine grinding and electrodes kind of technically, but the general benefits of this, I mean, what would be the benefit over if, let's say you had an eroding machine and a grinding machine separately? Surely it would be better to have a single grinding machine and a single eroding machine because they'd be the best at their respective disciplines, right? Why would you want to combine them?
But especially if you have a tool where you have to do both. That means you have to do the erosion in the erosion machine, and afterwards you have to go to the grinding machine. You are losing a lot of time, but also you are losing a lot of accuracy. Yeah, and this is the reason why this tool must be made in one single setup in the erosion of the V-Hybrid 260.
And accuracy is so important when you're making cutting tools, because if they're not accurate, your parts aren't going to be accurate. But surely, I mean, to me, this sounds like a really specialist machine. Surely there's only a certain very specialist markets that would want a machine like this, right?
The machine offers a really high flexibility. Flexibility, what causes, or what means the tools itself. That means we have the tool or the machine in the wood industry, aerospace industry, automotive industry. The machine gives you all the possibilities in the industry to do, especially if you need the highest efficiency or you need the highest accuracy. The machine offers all.
That's absolutely amazing. A machine as specialist as this could still be making tools for woodworking, which is, it could be from hobbyists to industrial all the way to aerospace, which is absolutely fascinating. Exactly. I guess it shows the flexibility of a PCD tool, yeah, but how difficult it can be to make them and how Vollmer, I mean, you try and making PCD tools as easy as possible.
Yeah, as you know, we have different programming systems in. That means you only have a drawing. From this drawing, you only need the parameter of the tool. For example, for this drill, you need the point angle, Yeah, you need a helix angle that's really easy programming. You have to.
And that's a combination of two very, very different materials, and yet you just still program it like it's just a standard spot drill.
That's really easy. Also easy to learn. Yeah, for the operator, that's not a big deal to do that.
Okay, so I guess the people who've been needing a machine like this, like you mentioned a shop, a grinding shop that is maybe buying their first grinding machine, they might want to look at erosion first because PCD is a big market and they want to make sure they're as flexible as possible to stay competitive in Germany, the US, and worldwide.
Yeah. And due to the flexibility, also a customer he needs a grinding machine now, but he doesn't really know what is going up in the future. Maybe he's investing in an erosion machine, he's starting with the grinding stuff, but maybe after 1 or 2 years time, he's able to switch it to PCD very easily. Yeah.
And you don't even need to change the way you program it. It's absolutely fascinating, Alex. If you've got any questions for Alex or for any of the Vollmer team, we've got 4 minutes left on the stream, so if you've got any questions, please get those in now. We'd be fascinated to find out how you use your Vollmer machine, or if you're looking at a Vollmer machine right now. Let's dig into the. Oh, can we open? Oh no, I guess we've got a demo running right now. So I'd like to. Oh, so we can see the robot moving now. I wanted to dig into the big roster of tools that you've got, you're making here, because there are some solid carbide tools that do show that you don't have to be just doing PCD, because sometimes they might be really low volumes PCD. You might want to make a few standard M mills as well.
Exactly. This is what we show here. We want to show here on the show the flexibility of the machine. That means it doesn't matter if now we want to do a PCD cutting tool, or maybe now we switch to a carbide tool. That's easy done by the programming, by the production program, and that's maybe the strength of the machine. You can switch very, very easily.
I still can't believe you can fit almost 150 tools on this little roster.
Yeah.
It takes up no space at all. It's amazing.
It's depending what clamping we are using, especially the wood sector, maybe most of all is using the HSK. Yeah. Very often, if we are talking about the aerospace and automobile industry, they are looking for the shank tool loading. And yeah, what we want to show here, maybe the flexibility of the machine, what you can do, what you can have in your shop.
Brilliant. Super flexible machine from Vollmer, new this year. I'm going to wrap up. That's from me and Alex. Over to Tony's got an exciting invitation for you.
Well, I hope you guys have enjoyed everything that we've talked about and learned about today. So we have one last message from my friend Peter.
Thank you very much, everybody. Yeah, it's been a pleasure. Thank you for watching the live stream. I'd like to remind you, please come to the Vollmer booth, 233-834, and we have a happy hour from 4:30 every evening. Please come and join us. Be a pleasure to meet you all. Thank you again.
And who doesn't love a happy hour? Thank you so much, my friends. You've done a wonderful job today.
Thank you.
And thank you all for watching.